Alright guys, so we're going to continue with our notes. We're looking at 7.4. We're going to be adding and subtracting rational expressions. So this kind of puts everything together. This builds off of 7.3, so hopefully you have a good foundation with 7.3. Alright, when you have the same denominators and you're adding or subtracting rational expressions or fractions, all you do is you keep the denominator and then you add the numerators. So if you have p over q plus r over q, then you just go p plus r over q. So to make that real, if I have 4 over 9 plus 2 over 9, my denominator is exactly the same, so I keep that 9, and then I go 4 plus 2. And 4 plus 2 would be 6 over 9. Now, when I'm dealing with fractions, I got to make sure that they're all the way down, all the way reduced, just like I have to do with rational expressions as well. So what goes into 6 and 9? 3. So if I divide 6 divided by 3, I'm going to be left with 2. And if I go 9 divided by 3, I'm going to be left with 3. So my final answer would be 2 over 3. This is going to be super important. Make sure that you reduce your fraction or rational expression as much as possible. So now we have 3x over x plus 1 plus 3 over x plus 1. So again, we keep the x plus 1. And then we add the top, so I go 3x plus 3. Okay, I can't combine those two because the terms aren't exactly the same. But what I can do with my numerator is I can clean this up. When I clean it up, I got two terms, so it either can be a GCF or a difference of perfect squares. This is a GCF, and I can pull out a 3. When I pull out a 3, I'm left with x plus 1 over x plus 1. Now, just like we did in this chapter so far, if I have anything over itself, it will cancel out, so really my final answer will just be 3. So if you have the same denominator, you keep that denominator and you add or subtract straight across. Now, when you add or subtract expressions with different denominators, the first thing you have to do is you have to find your least common denominator, so you have to find your LCD. How you do that, remember, is you factor, then you ask how many, and then you multiply the max. Alright? You're going to rewrite each rational expression as equivalent rational expressions with the LCD in the denominator. So that's what we did at the end of our notes on 7.3. And then you're going to add or subtract the numbers. Add or subtract the numerators to get the numerator of the sum or the difference. So basically you're going to add or subtract the top, and then the last thing you have to do is you have to write in lowest terms. Okay? So let's do this. Let's start off with just a fraction. So if I have 1 over 10 plus 2 over 15, the first thing that I want to do is I want to look at my denominators, and I notice they're not the same. So I have to find my LCD. Okay? For 2 and 15, my least common denominator is going to be 30. Okay? If you can't automatically see that, you totally can go through the process. So to find my factors of 10, that would be 2 and 5. To find my factors of 15, that would be 3 and 5. They're prime numbers. So then I ask the how many. And I put my max. So I'm looking at how many 2's, how many 3's, and how many 5's. So I see that I have 1, 2 here, 0. I've got 0, 3, 1. I've got 1, 1. Now I deal with my max, so that would be 1, 1, 1. So my LCD would be 2 to the first times 3 to the first times 5 to the first. And 2 times 3 is 6. So 6 times 5 would leave me with 30. So if you need to do this process, go for it. I'm not going to do it for each one, but just to show you. So step 1, find your LCD. Step 2, we have to make equivalent fractions. So 10 times what gets me to 30? Got to multiply by 3. So I'd go 3 over 30 plus 15 times what gets me to 32. So 2 times 2 on the top, so that would be 4 over 30. My denominators are the same, so I've got 30. I add my numerators, so 3 plus 4. which would be 7 over 30. The last thing I gotta do is I gotta decide, hey, can I reduce this? And 7 over 30 does not reduce, so that's as far as you can take it. Alright? Now, let's look at the next one. Whenever I have rational expressions, I do something slightly different just to make it more clear. So, and I'll show you, it deals with your LCD. So I've got 4 over 3m minus 6 plus 5 over m minus 2. I see that my denominators are not the same, so I know I'm going to have to find my LCD. In order to find my LCD, first thing I have to do is factor. I have two terms, so I can pull out a GCF, so I can pull out a 3, and I'm left with m minus 2. So I see that I have a single of 3, and that would be raised to the first power. So I can just write down the 3, and then I have m minus 2. This would be 1, this would be 1, so my max would just be 1, so my LCD is 3 times m minus 2. So now what I'm going to do is I'm going to compare my LCD, which we just found, to each term, or to each denominator, and see what's missing. So 3 times m minus 2, 3 times m minus 2, nothing's missing, so I don't have to multiply anything to my first one. So I'm just going to have 4, and instead of writing what my LCD is, I'm going to actually just write down LCD. The reason why is it makes it a lot clearer as you work through it. Now, what's missing for my second denominator in my LCD? The thing that's missing is the 3, so I'm going to multiply my bottom by 3. I have to multiply my top by 3. So I've got 3 times 5, which would be 15 over my LCD. Okay, so my LCDs are exactly the same, so I'm going to go LCD, and then I'm going to add my numerators. So 4 plus 15 would leave me with 19. Now, I'm going to look at my numerator. Is there anything else that I can cancel out? The answer to that is no. So I'm going to have 19 over 3 times m minus 2. And then the last thing that I'm going to do is I'm going to check to see if I can cancel anything out. 19 and 3 doesn't do anything for us, so I box my answer. So the new thing that I did with this is instead of writing out the LCD each time, I just put the LCD because it doesn't change until I finish cleaning up my numerator. Okay? Let's try this one. So I've got 2k over k squared minus 5k plus 4 plus 3 over k squared minus 1. Alright, first thing that I look at, my denominators are not the same, so I have to figure out what my LCD is going to be. In order to find my LCD, I have to factor my denominator. So if I look at my denominator, I have 3 terms, so it either can be an a equals 1, it could be a doesn't equal 1, or it could be a perfect square trinomial. For this one, it's an a equals 1, so I'm going to go parenthesis, parenthesis, k, k. It's minus plus, so that has to be minus minus, and then I find my factors of 4, 1 and 4, and 2 and 2. It has to be minus minus to get to my b, which is negative 5. So this would be 1 and 4. Alright, then I have k squared minus 1. I have 2 terms, so it either can be a GCF or it could be a difference of perfect squares. This one is definitely a difference of perfect squares. So I take the square root of k squared, which is k. I take the square root of 1, which is 1. I set up my parentheses. I go plus minus, so I got k plus 1 and k minus 1. Alright, now for my LCDs, I have to ask the question of how many. So the first one I see is I see k minus 1. So how many k minus 1s do I see in my first set of factored form? I see 1. How many do I see of k minus 1 in the second one? I see 1. Okay, now, so my max is just going to be 1, so it's just raised to the first power. Now I've got k minus 4. I have 1, I have 0, so my max is going to be just 1. And then the last one I have is k plus 1. Okay, and I don't have any k plus 1s here, so that would be 0, and then k plus 1 would just be 1. Okay, so this is going to be my LCD, and this is why I write LCD, because it's a lot to write. So that's step 1. Step 2, we have to make equivalent fractions. So I compare my LCD to my first denominator, and I ask myself what's missing. So the only thing that's missing from here to here is just the k plus 1. And what I do to the bottom, I have to do to the top. So I'm literally just going to write it out. I'm going to go 2k times k plus 1 over LCD. Okay? Now, I'm going to compare my LCD to the second term. And what's missing here is just the k minus 4. What I do to the bottom, I have to do to the top. So I go plus 3 times k minus 4 over LCD. Now the reason that I keep it like this and put the LCD is because I still got to clean up this top. Alright, so with this, I've got to distribute. So I've got to distribute this 2k to the k and 2k to 1. So if I do that, it's going to be 2k squared plus 2k over LCD. And again, I have to distribute, so I have to distribute this 3 to both terms. So 3 times k is 3k, and then 3 times negative 4 is negative 12 over LCD. Now, on 43 and 47 of your homework, instead of distributing, what you're going to have to do is you're going to have to FOIL. So, for 47, you'll have something that looks like this. 5 minus t times t plus 2. So right here, what you have to do is you have to FOIL the 2. Okay? So remember, first, outer, inner, last. And then you'll be able to clean it up from there. Okay? So, make sure that you distribute or FOIL when you need to. So now what we got to do is our LCD is the same. So we're going to keep the LCD and we're going to squish together or put together your numerator. So I've got 2k squared plus 2k plus 3k minus 12. Alright, and if I look at this, it'll be 2k squared, combine my like terms, so plus 5k minus 12. Alright, over my LCD. Now, if I look to clean this up, I've got 3 terms. It can either be an a equals 1, a doesn't equal 1, or it could be a perfect square trinomial. So if I look at this, this is going to be an a does not equal 1. And for this section of 7.4, I do not want you to go any further. So if you get a equals 1, I want you to stop right there because it won't end up cleaning up for this section. So I don't want you to have to waste your time. Okay? You will have 2 problems like this for your homework. So once you get to the point of a equals or does not equal 1, you can stop because you can't clean this up, and then you would just put your LCD. So that would be k minus 1 times k minus 4 times k plus 1. So just go back up and look right here. And this is going to be my answer. You don't need to take it any further from there because nothing's going to cancel. Now, let me go back to up here just in case you need a little bit more practice with the FOIL thing. So this is going to be like 47 in your homework. So what you'll have to do is you have to FOIL. So when you do first, you go 5 times t, so that would be 5t. 5 times 2, so that would be plus 10. And then negative t times negative t, which would be negative t squared. And then plus 2t. Now we got to make sure and put it in standard form. So we got negative t squared, combine our like terms, 5 and 2, plus 7t, plus 10. So that's how you would FOIL it and clean it up. Just so you can look at it later like that. Okay? Alright, so this is definitely a lot, so I want to go through it one more time really quickly. First thing you do is you find your LCD. In order to find your LCD, you have to factor, and then you have to ask the question how many and raise it to the max. Once you find your LCD, you have to take your LCD and you have to compare it to each denominator. So this one, what's missing is k plus 1. What we do to the bottom, we have to do to the top. And I want you to literally write that part out and put it over the LCD. Then we compare our second denominator to our LCD, and we see that we're missing a k minus 4. So we go 3 times k minus 4 over LCD. In order to clean up our numerators, we have to distribute. So make sure that you distribute and show that step. Once you distribute it, then you can add them together. And if you get a trinomial, remember it's a equals 1, a doesn't equal 1, or it's a perfect square trinomial. And if you get an a doesn't equal 1, you're able to stop right there for this homework assignment. Okay? So that's definitely a lot. Now I want you to try. So pause the video. This one's not as hard as the last one. And I want you to work this one out. Alright, so if we have x over x minus 2 plus negative 8 over x squared minus 4, first thing I notice is my LCD, or my denominators are not the same, so I need an LCD. I look to see if I can factor the first one. I can't. I got x squared minus 4, 2 terms, so it's either going to be a GCF or a difference of perfect squares. This is a difference of perfect squares, so I take the square root of x squared, which is x. I take the square root of 4, which is 2. I set up my parentheses. I go plus minus, so x plus 2, x minus 2. Alright? So now I look at my factors. I've got x minus 2, and that's my max would be raised to the first power. And then I have x plus 2, and that's going to be my LCD. Now I have to compare my LCDs to each term, and that's going to be step 2. Making equivalent fractions. So if I compare my LCD to my first denominator, what I'm missing is x plus 2. What I do to the bottom, I have to do to the top. So I've got x times x plus 2 over LCD. Then I compare my second one to my second denominator to my LCD. There's nothing that's missing. So I'm going to go plus negative 8 over LCD. And then I've got to clean up my numerators. So I've got to distribute this x. So x times x is going to be x squared. X times 2 is going to be 2x. And then over LCD plus negative 8 over LCD. So I've cleaned up my numerators individually as much as possible. So now I have to put them together. So I get x squared plus 2x minus 8 over LCD. I look at this, I have 3 terms. So if I have 3 terms, it's either an a equals 1, a doesn't equal 1, or it is a perfect square trinomial. This one is an a equals 1. So I set up my binomials, x plus minus, factors of 8, 1 and 8, 2 and 4. I have to use subtraction to get to my b, which is going to be a positive 2. So I've got to go 4 minus 2, put my 4, put my 2. I factored it out as much as possible. So now, instead of writing LCD this time, I'm going to come up here, I'm going to write down what my LCD is. So I got x minus 2, x plus 2. Now I look to see if there's anything that I can cancel out so I can reduce this rational expression. The x minus 2's cancel out. I'm left with x plus 4 over x plus 2. Hopefully you got this one right. If not, make sure that you watch it until you get it right, please. Alright, so now that we've worked with addition, now we have to work with subtraction. So to subtract, make sure to include the minus sign when combining the numerators. Make sure to put parentheses around the second numerator and distribute the negative 1. So whenever I see a subtraction problem, the first thing that I do, I haven't even read my problem, is I'm going to put parentheses around my second numerator. So I have 2x over 5 minus x minus 3x plus 2 over 5 minus x. Now, since my denominators are exactly the same, I can keep that denominator of 5 minus x, and I'm going to put together my numerators. So once I do that, that would be 2x minus, in parentheses, 3x plus 2. Now, because it's minus, what that really means is I'm putting an invisible 1 right there. Okay? And what I have to do is I have to distribute this negative 1 to both parts of the second numerator. And that's why it's super important for you to put the parentheses there. So if I clean this up, I've got 2x minus 3x minus 2 over 5 minus x. I continue to clean this up. and I combine my like terms, so I've got negative x minus 2 over 5 minus x. Alright, then I look to see if I can cancel anything out. I cannot, so there's my answer. So the big difference between addition and subtraction is you have to distribute the negative 1 to whatever your second numerator is. Okay? So let's make this real. If I have 3r over r squared minus 5r minus 4 over r squared minus 10r plus 25. The first thing that I see is I have a subtraction problem. So whatever my second numerator is, I'm going to put parentheses around it. Okay? Next thing I notice is my LCDs are not, or my denominators are not the same, so I need an LCD. In order to do this, first thing I have to do is I have to factor. So if I have r squared minus 5r, I have two terms, so it either can be a GCF or a difference of perfect squares. So I pull out my GCF, which is going to be an r, and I'll be left with r minus 5. For this second one, I've got r squared minus 10r plus 25. Alright, this one, three terms, so it's either a equals 1, e does not equal 1, or it's a perfect square trinomial. So there's two ways to look at this. You can either look at it as an a equals 1, or you can look at it as a perfect square trinomial. I am going to look at it as an a equals 1 just because that's a little bit more obvious. So I put my parentheses, I put my r, then I have minus plus, so that would be minus minus, factors of 25, 1 and 25, and then 5 and 5. I go minus minus to get to my b, which is negative 10. So that would be 5 and 5. I put my 5, I put my 5, and I've factored it as much as possible. The next thing I have to do to find my LCD is I have to ask how many. So I know I'm going to deal with my single variable by itself first, so I've got my r. And then I've got to deal with the r minus 5. And I've got to look at my max. So for my first denominator, I only see 1, but for my second denominator, I see 2. So this would be r minus 5 squared, because that would be my max. So therefore, that is going to be my LCD. Okay? So now what I need to do is I need to compare my LCD to each denominator. So what is missing from this LCD to my first denominator? And what's missing is r minus 5. What I do to the bottom, I have to multiply to the top. So when I rewrite it, I've got 3r times r minus 5 over LCD minus 4 in parentheses. Okay? And what is missing from this to my LCD? All that's missing is an r, so I'm going to multiply my bottom and my top by r over LCD. Okay? So now I'm going to distribute. So I've got 3r squared minus 15r, and then over LCD. And then actually, I'm going to go ahead and combine it all together right now. So then I've got negative 4 times r is 4r. Okay? Now, for this one, if I was distributing the negative 1, it just changes it up just a little bit. So I've got 3r squared minus 15r minus 4r over LCD. You don't necessarily need to show that point if you see it right here. So now I combine my like terms, so I've got 3r squared minus 19r over LCD. Still can clean up my numerator. I can pull out a GCF. GCF that I can pull out is going to be r, and I'll be left with r minus 19. I've cleaned it up as much as I possibly can, my numerator, so now I can just write my denominator of r times r minus 5 parentheses squared as my LCD. And the only thing that cancels out is the r's, so I'm left with r minus 19 over r minus 5 parentheses squared. Again, if you want to keep that in parentheses, you can. If you don't, that's okay too. So the biggest thing with subtraction is you gotta make sure and be careful with that -1. Okay, let's try another one. So we've got 2 over a plus 3b minus 5 over a minus 3b. Alright, so first thing that I gotta do is I gotta look to see if my denominators are the same, which they are not, so I'm gonna have to have an LCD, and actually that's not the first thing I'm gonna do. I see that it's subtraction, so I'm gonna put my parentheses, I'm sorry about that, over my second numerator. So now I'm gonna look at my LCDs, see if I can factor anything. I can't pull anything out. I can't pull anything out. So when there is nothing that you can factor, your LCD is literally just going to be a plus 3b times a minus 3b, because there ain't nothing that they have in common with each other. Okay, so now I'm going to compare my LCD to each denominator. So what I have to multiply this first one by is a minus 3b. What I do to the bottom, I have to do to the top. So I've got 2 times a minus 3b over LCD minus, in parentheses, a 5. Okay, what I'm missing here is a plus 3b. So a plus 3b. So times a plus 3b over LCD. Alright, so what I got to do is I've got to distribute the 2, and I've got to distribute the 5. So 2 times a would be 2a, 2 times 3b would be 6b over LCD, minus 5 times a would be 5a, 5 times 3b would be plus 15b. Now, it's super important to make sure that you keep that all in parentheses, because it's still a subtraction problem. Okay? So now I'm going to put it together, and I'm going to go 2a minus 6b minus, in parentheses, 5a plus 15b all over LCD. And now I've got to distribute this -1. So I've got 2a minus 6b minus 5a minus 15b over LCD. Okay? Now we gotta combine our like terms. So when we combine our like terms, what's gonna end up happening is I've got 2a minus 5a, so that's gonna be -3a. Then I got -6b minus 15b, so that's going to be minus 21b over LCD. And again, I can clean this up a little bit more. What I can do is I can pull out a GCF. My GCF is going to be -3, and when I pull out a -3, I'm going to be left with a plus 7b. And I've cleaned that up as much as I possibly can, so now I can replace it with my LCD. So I go a plus 3b times a minus 3b. And this is as far as I can take it. These are definitely tedious problems, but they shouldn't be too bad if you take it step by step. Okay? The last thing that we have to do is we have to add or subtract with opposite denominators. So in 7.1 you learned that opposites simplified to -1. So if you have x minus y over y minus x, if they're in opposite positions and they use subtraction, they're going to reduce down to -1. And then in 7.3 you learned that you can pick either one to be your LCD. So to add or subtract with opposites, what you want to do is you want to pick, this should be 1, not on. So you need to pick 1 to be your LCD. I usually pick the first one I see, just for consistency's sake. And then step 2, you have to make equivalent rational expressions with the non-LCD by multiplying the numerator and the denominator by -1. So let me show you what I mean. Okay, so first thing, I see it's a subtraction problem, so I want to put parentheses around my second numerator. The next thing I see is, I'm going to read the problem. So I got 6 over x minus 3 minus 1 over 3 minus x. So I see that these two are definitely not the same. They are in fact opposites of each other. So for my LCD, I can pick either one and it would be good as gold. So I'm actually going to pick the first one I see. So my LCD is going to be x minus 3. So now I compare my LCD to my first denominator. There's nothing that I need to change, so I'm going to go 6 over LCD minus. In order to change my second denominator to look like my LCD, all I have to do is multiply by -1. So I multiply the top by -1 and I multiply the bottom by -1. Because what I do to the bottom, I have to do to the top. So I've got 1 times -1 over LCD. So if I clean this up, this will be 6. And then technically this would be 6 over LCD minus -1, but that's in parentheses over LCD. So if I rewrite this to put it together, this would be 6 minus -1 over LCD. So this would be change. So this would be 7 over my LCD, which would be x minus 3. Okay? Now, if you saw it right here, or actually, if you see it right here, so if you got -1 times -1 to see that to be a positive 1, then you can go straight to 6 plus 1 equals 7. But this is kind of the process if you want to do it step by step. Okay? So again, if you have opposites, choose one of them to be your LCD. I always choose the first one. And then the second one, in order to make an equivalent fraction, equivalent rational expression, you're going to multiply by -1 on the top and on the bottom. Okay, so let's look at B. First thing I notice, it's a subtraction problem. So I'm going to go ahead and put my parentheses over my second numerator, and now I'm going to read the problem. So I've got 4x over x minus 1 minus -3x minus 1 over x, or 1 minus x. So the first thing I notice, I got my denominators that are not the same, so I've got to find my LCD, and they are opposites of each other. So since they are opposites of each other, I'm going to choose the first one that I see to be my LCD. So I'm going to go x minus 1. I compared the two. I don't have to do anything to the first one, so I've got 4x over LCD minus, and then in order to change the second one, I've got to multiply by -1. So I've got -3x minus 1 times -1 over LCD. So let's distribute this -1 to both parts. And if you wanted to put it in front of it, you could have as well. So we've got 4x over LCD minus -1 times -3x is going to be a positive 3x. -1 times -1 is going to be plus 1. But remember, it has to be in parentheses because it's a subtraction problem over LCD. Now when I put those together, I've got 4x minus 3x plus 1 over my LCD. I'm going to put my little imaginary 1 in there, and I'm going to distribute the -1. So I've got 4x minus 3x minus 1 over LCD. Combine my like terms. 4x minus 3x is just x minus 1 over my LCD, which is x minus 1. So my final answer would just be 1. Alright guys, I hope this helped out a little bit. Please make sure to rewatch if you don't understand it, because you have to have a good foundation for this in order to do 7.4. So go ahead and try those homework problems. And remember, for 43 and 47, you are going to have to FOIL. So please make sure you get that knocked out. Make sure you show all work. Thank you.